Hello guys, today we'll be talking about parent functions. Okay, before I go into this lesson, I want to give you guys a quick heads up. This lesson will include parent functions, but they will also include some things about transformations. And the domain range of these parent functions are in relation with their transformations. However, you guys don't need to know if a certain amount of transformations to understand the lesson. Okay, so you guys don't have to know transformations in order to do this lesson, even though some of the things in this lesson are in relation to transformations. So I will also include those stuff in this lesson, but if you guys don't know or do not want to do those things, those questions like these, then you guys feel free to just skip over those parts where I talk about those examples. Okay, so first of all, a parabola. Our first parent function is a parabola. And a parabola curves up like this, or curves down. It's a U shape. Okay, and this is a basic table of values. So let's fill them out and see how it curves. So f of x equals x squared. So negative 2 squared is 4. 1, 0, 1, 4. So let's just graph that real quick. Got that, that. Okay. Let's curve upwards like that. And there you got it. That's your quadratic function right there. And for domain range, the domain is XCR, right? Which means X is an element of all real numbers. You would express like this. So your domain like that, and your range would be YER, such that Y is either smaller, such as Y is either bigger or equals than, or smaller and equals than the Y coordinate of the vertex, depending on if it's flipping upwards or downwards, basically. That's what a vertical reflection means. Okay, so for this one, the vertex is at 0, 0. So our range would be YER, such that Y is bigger or equal than 0. Okay, well, if this parabola were to curve downwards like this, okay, if it were to curve downwards like this, then it will be smaller than, because it curves downwards. Okay, that's what a vertical reflection means. So yeah, like assume there's a negative here, then you will flip the sign from this to this. Okay, so that's how you find the domain range of a parabola and the basic characteristics of a parabola and its graph. Okay, so let's do some questions. So the domain range of this, just to give you a clear idea, so our domain XER always for parabola, and our range will be YER, such that Y is smaller or equals than 3. Right, this is in vertex form, and this is always the Y coordinate of vertex. Okay, so this one is the same thing, but notice there's no negative here, so it's going to be larger than 3. Okay, that's your range. So range there you go. Okay, now onto square root functions. Square root functions, so let's start off with filling in the table values. This is going to be your parent function. Okay, f of x equals root of x. Root of negative 1 is nothing. Root of 0 is 0, like nothing, as in there's no value. Root of 1 is 1, 2, and 3 here. So graph that. Okay, so the curve is going to be like this. Very nice. Okay, So your domain is going to be, for the parent function, the domain is xcr such that x is bigger or equal to 0, and your range for this parent function is going to be yer such that y is bigger or equal to 0. Okay, that's going to be your set of domain range for this parent function. But in general, the rule for this type of graph is that let's say you have y equals negative root x plus 3 minus 2. Okay, so your domain of this graph, for example, is going to be, you're taking this whole thing inside, like you're just extracting the whole thing inside the root, so x plus 3, and you're setting it bigger or equal to 0, because as you guys see in the table values, right, you can square root any real number as long as it's bigger or equal to 0. Okay, so you set the whole thing inside the root equal or larger than 0, you solve for x. So that's your domain right there. The domain is going to be xcr such that x is larger or equal to negative 3. And then your range, okay, is going to be yer such that, so yer such that y is bigger or smaller with a vertical shift, meaning this value here. Okay, so in the parent function is plus 0, so it's going to be 0. But this one is going to be negative 2, right? So we know that y is either bigger or 0 or smaller depending on the reflection just of the parabola. Okay, so this one has a reflection, therefore it's going to be smaller than. Okay, very nice. Okay, now this, okay, never mind. Let's do one more problem here. So domain range of this, okay, so domain, just set the whole bracket bigger or equal to 0. This is your domain. Domain is xcr such that x is smaller or equal to 3. Your range would be yer such that y is bigger or equal to 2, because there's no reflection here. Okay, this in the inside the bracket there is a reflection. You factor out negative, you get this. So yeah. Okay, let's go on to absolute value functions. First, let's just graph that. So let me 1, 2, 1, 0, 1, 2. Okay. Arrows at both ends, obviously very important. Alright. Your domain range of the parent function is going to be x er, and your range will be yer such that y is bigger or equal to 0. For transformed graphs, okay, then your domain will be also xcr, but your range will be yer such that y is bigger or equal to or smaller than or equal to the whatever vertical shift you have. So what I mean by vertical shift, same thing as here, right? Vertical shift is this value. So whatever it is at the end, basically. So if y equals x plus 2 minus 3, this is a number you have to pay attention to when you're doing the range. And to determine if it's bigger or equal to or smaller or equals to, you do the same thing as you did for the parabola. Okay, if it's reflected, say it's a negative here, then it becomes smaller than or equal to 0. Okay, so for this graph, it's going to be y is bigger or equal to negative 3 because there's no reflection. Okay, let's try example. Domain xcr, curly brackets, closing it, of course. So yer here, y is smaller or equal to 2. Okay, now on to reciprocal functions. Let's just graph this first. Okay, this is gonna be a hassle. This is probably like one of the worst functions, but it's not like hard, but it's like annoying, I'd say. Okay, so let's just graph this real quick. I'm going to draw something called an asymptote. An asymptote is essentially a value that a function approaches but never actually reaches. Okay, I'm just going to draw it first, and then I'll graph it and you guys can understand what I'm saying. Okay, so let me just graph this. -2, -1/2, 1/2, 2. Okay. So this is what the graph looks like. Basically just two curves. Alright. And an asymptote is like basically if you extend the limit, like if this graph just goes on to infinity, right, it will go closer and closer and closer to this green line, but it never actually reaches it, right? And same thing with the purple line. Vertically, if this thing goes up and up and up, if you extend this vertically to infinity, it will always go closer and closer and closer to this purple line, but it never actually reaches it. That's what you call an asymptote. This is called a vertical asymptote. This is a horizontal asymptote. For a reciprocal function, the vertical asymptote is basically this thing. Okay, so for this parent function, the vertical asymptote is x is equal to 0. The horizontal asymptote is y equal to 0. And the horizontal asymptote is basically found taking the vertical shift. Okay. The vertical shift in this case is 0 because it's a parent function. So the domain, if you guys are smart, you guys can deduce using what I explained earlier, you guys can come up with your domain. Obviously, x cannot be 0 for this parent function, because even if you extend this to infinity, right, your x could never reach 0. And then your range, BYER, such that y cannot be equal to also 0 for the parent function. Because as long as you extend this, whatever, your y value of this function will never get to 0. Okay? And for any transformed reciprocal function, okay, your vertical asymptote is going to be like setting this whole thing, it cannot be equal to 0. So XER such that x cannot be equal to the vertical asymptote, and YER such that y cannot be equal to the horizontal asymptote. Okay, basically you just set this whole bracket as not equal to 0. Okay, so what not equal to 0? Why? Because here, if you guys can see, when the denominator is 0, because x is in the denominator, then you get an undefined value. You should try plugging in 7/0 or like any real number over 0, you get undefined or math error in your calculator, right? So we're just assuring that we find the asymptote by saying when at what x value, right, would make this function undefined. So we can do that by saying 4x minus 2, setting the whole numerator is not equal to 0, solve for x, okay, and your vertical asymptote is found. And your horizontal asymptote is basically this value here. So that's your horizontal asymptote. There. Your vertical shift right there. That's your horizontal asymptote. Therefore, your domain is XER such that x is not equal to the vertical asymptote, which is x equals 2. Range YER such that y cannot be equal to the horizontal asymptote at 3. That's your reciprocal function. So if you guys enjoyed this video, please leave a like and also subscribe.